lecture on the subject of automated soft fruit picking. Simon is the director of the Lincoln Institute of Agri-Food Technology, LIAT, which sits within the College of Science at the Uni of Lincoln. He will tell us an awful lot about the projects which he's involved in, I am sure, so I'm not going to rattle on and on about that, except to say that he helps develop and run cross-disciplinary research projects on behalf of the agri-food sector. And if you don't know what that means, hopefully by the end of this presentation we'll be a little bit clearer on that. Simon has been involved in practical agriculture as well. He was a CEO of a large UK farming company. He's worked for Marks and Spencer in a technical role and as a scientist at the University of Reading. So he's covered a bit of ground in his time. But I'm going to leave you with Simon now, and Simon will put his slides up as well. And away we go. Thank you, Simon. Thank you for taking part.
Hey, thank you very much. Okay, I'll just say next slide. Well, thank you for this opportunity to chat to you all and for spending an hour at lunchtime with us. What I'd like to do is really discuss what I call case for Agri-Robotics. Give a quick overview of some of the work we're doing at Lincoln. And show our strategy around agri-robotics, and then, as Andy said, really sort of show some use cases around the work we're doing in fruit picking and soft fruit picking. So a little background about Lincoln. So Lincoln, I'm director of Lincoln Institute of Agri-Food Technology. We operate at the Rhizome campus, the University of Lincoln. That's a 200 hectare LIAT, and we have a very large focus around agri-food technology, and particularly agri-food robotics. And then some of the core investments quite recently have been, we've got a Centre for Doctoral Training in Agri-Food Robotics with Cambridge and UEA. That's a cohort of about 50 PhDs over 8 years. We have 5 in year 1, then it goes 14, 14, 14, 14. So that's going well, and we've recruited the full 14 cohort this year. And then we were recently awarded £6.3 million by UKRI Research England to form Lincoln Agri-Robotics. That's 30 members of staff, 1 professor, 2 at associate professor level, and some more PhDs, some postdocs, lecturers, research staff, so on. So quite well-resourced institute. And then at Rhizome, we're just installing, I think, one of the UK's first private 5G networks, which is a standalone 5G network. It's only the second one put in by BT in the UK, and that will be used for telecoms and advanced communication data transfer around the use of agri-robotics. So quite nice facilities, and the university's been investing very actively in this space. Next slide, please.
Good line.
Sarah, is that? Hello, Sarah. Sarah, could you click on the next slide, please? Where's Sarah? Oh, here we go. Yeah, thanks, Sarah. So what I wanted to really give a view was almost like a Donald Rumsfeld type. Oh, sorry, no, let's start again. Okay, so we have a lot of core facilities at Rhizome, and then recently we wrote for UKRI what we think was a key white paper on the future of agricultural robotics. And this is a paper authored by a colleague of mine, Tom Duckett, with Simon Blackmore at Harper, myself, Bruce Grieve at Manchester, and quite a large quite a large proportion of the agricultural robotics in the UK contribute to that white paper. And what we think is that agricultural robotics have got a real significant and transformational role in the future of agriculture. We particularly at Lincoln focus on crop agriculture, so arable agriculture. We don't do any research on animals as such, so we focus on crop plants and arable and horticultural crops. And we think agricultural robotics, it's a fantastic combination. So it's of great interest to the roboticists. So what we show here is on this screen a sort of a top half and a bottom half, but in agriculture the roboticists are really interesting because there's some very significant challenges in manipulation and grasping. So how do you do robotic control to actually pick a strawberry or pick a crop? Very, very challenging manipulation and grasping issues. Great interest to roboticists. It's great interest to computer scientists for image processing and machine learning and recognition. So how do you identify a fruit? How do you identify a weed in a crop? How do you identify the phenology of a crop? So some really foundational work that needs to be done in vision systems. Then the area we're particularly interested in at Lincoln is how one machine alone won't solve these problems. So how do you operate fleets of autonomous systems? So we see a future with many, many robots. So in fruit picking, the work we do at the moment, there are 30,000 fruit pickers today on soft fruit farms throughout the UK picking fruit. Well, they're not going to be, they're not, to drive productivity in that sector, that's going to need many thousands of robots. So how do you get those robots operating as a fleet on a farm? How do you do it safely? And then if you've got a very large fleet of robots, how do you handle the gargantuan amount of data that those robots are generating? And if you think of a fruit picking robot in terms of gargantuan amounts of data, we have a strawberry robot that has 2 RGBD cameras on it. We have another one with a hyperspectral camera. Each robot might have 3 or 4 LiDAR sensors. So they're generating vast amounts of data, and that's on a single robot. Once you start to have a fleet of robots, then clearly it's just multiplicative by the number of robots you've got. So there's vast amounts of data that need to be transferred and processed in real time. So we think data handling is going to be key, and that's why we're investing in 5G. Then you've got another problem where the robot people are very interested to be autonomous. So how do you develop autonomy? It's really quite challenging in agriculture because you've got non-structured environments. You can't use row following very easily. In some environments you have a GPS system, so you can get some guidance through the GPS system, but that still needs to be autonomous. But if you go into horticulture crops where you've got greenhouses or plastic tunnels, then that's a GPS denied environment. So there's some really complicated challenges on how you make vehicles autonomous in GPS denied environments. So the robotics challenges are really very interesting for the robotics community. So that's the bottom half of what we do. The top half, which is really where I'm from, is the AGRI challenges. And robotics have got, we think, a transformational impact in agriculture. And the one that we're focused on today, we're calling selective harvesting. So how do you get robots to go in and harvest crops? That's really quite, that's not there's a lot of research that needs to be done to underpin that and make that robust. And I'm going to talk about that in a minute. But the other areas are phenotyping. So we have some quite big programs now on fleets of robots which are monitoring crops. So it might be plots of wheat, deploying very, very sophisticated sensors, again, hyperspectral cameras or LiDAR, other sensors, multi-spectral LiDAR, systems to support plant breeders in what we call phenotyping. So it's monitoring crops, trying to find new traits for to advance plant breeding, and all those sort of things. So phenotyping is becoming very data intensive, and we're seeing a very large role of robotics in that. And if you think of phenotyping, you could have big plant breeders might be producing several thousand plots of wheat, and they're trying to identify a handful of the best ones in several thousand plots. Lots of them are still doing that with frankly, students and clipboards. And what we think is robotics with advanced sensors are going to be key to trait development and selecting new varieties through phenotyping. So that's a big part of research. The other area, the final one, is on what we call crop care, where you might have robots going around monitoring carbon on farm. So we have a robot which wanders around, can measure carbon flux at high spatial resolution. Might be robots which identify weeds for weeding. It might be robots, or it might be the data science applied to a UAV for scanning the environment. So lots and lots of opportunities around robotics and data-driven technologies in agriculture. Most of when people see a robot, people often think of the hardware, the complexities, the software, and that's, I guess, that's where most of our research is, in the software applications. So next slide, please, Sarah. So what I want to do now is just really reflect on fruit picking, and this is one of the big challenges. And with COVID, it's becoming a pressing challenge. And I guess we've been really active around this space for the last 4 or 5 years. And that's really reflected the pressure that's come on the industry on a number of fronts. So about 4 years ago, the government introduced the national living wage. That increased salary pressure on the industry, so it needed to drive productivity. Then along came Brexit, and it's famously the great majority and the vast majority of fruit pickers in the UK and veg pickers are EU migrant workers. And with Brexit and the new immigration bill, those people, unfortunately, and I hate this term, that their term is low skilled workers. In fact, I think they're actually low paid workers. To do that job is actually really quite skilled. You've got to be trained to do it. You've got to be physically fit, and you've got to know what you're doing. So this word low skilled, I think, is really unfortunate. I think they're low paid workers, but with changing government policy, there might be restriction on the access of those people into the industry. So the industry needs to automate. And then I guess COVID's then really come on, and COVID's really several times worse than anyone expected with Brexit, has really affected the availability of workers in the sector. And most of the fruit pickers in the UK weren't in the UK in March. The industry had to fly in charter jets to get fruit pickers. But it's put enormous pressure on the industry. So there's great interest in automation. This picture just shows fruit picking in 1980, and to show you where fruit picking is today, that's here. So in 2020, over the last 40 years, it really hasn't changed a great deal, and it's still a trolley being pushed by pickers through farms. It's genuinely physically very hard work, and they don't get paid a huge amount of money. That's in fruit. And just to show you the next slide, it's the same in veg picking, and this is a Lincolnshire scene of collie cutting. That hasn't really changed again in 40 years, and it's backbreaking work. It's particularly hard in veg picking because you're outdoors, and Lincolnshire environment we get the odd day when it's really nice, but we get many days when it's pretty cold, horrible, wet and manky. So lots of needs for automation. And next slide, please, Sarah. And these are what I call the known unknowns. So we know about COVID-19, we know about Brexit. The unknown to the industry is what's going to happen to food security with these impacts in the short to medium term, and at what cost. And I think the cost issue is the one that's really come through this knowledge is that the costs are going up. So most of the fruit is being picked, but it's a substantial cost increase per hour of labour employed. That's a very serious problem for the industry because it's a very high volume, low margin industry. So if the costs go up, it's very hard to pass that back to the retailer, and normally that cost increase is borne by the grower. So that's the untold story of COVID, which will come out sadly probably over the next few months. So we'll see what happens. So next slide, please. So at Lincoln, what we've been doing along with Agri-Epi, who we collaborate very actively with, so Agri-Epi and Lincoln have really been looking at can robotics help around COVID-19, and Dave Ross and I in May this year ran a series of webinars to see whether there's any way we could accelerate use of robotics to help the fresh produce industry. And we ran, I think, 4 or 5 webinars which had a very large proportion of the fresh produce sector and a very large number of the robotics community on those webinars to see if there's anything we could do, rather like the ventilator challenge, to push things forward and see if we can get robots into action much faster than we expected. And we held some webinars, we captured some data and we captured them in word cloud, and this is what the agri sector was saying: real concerns about labour. All of them were seeking automation, and none of them were expecting automation tomorrow, but they needed it in a 12 to 18 month period. And these word clouds just capture the sentiment. So they look for tech solutions. They need accelerated investment in robotics. A lot of them might rethink crops for next year. Some the robotics community, what they needed to accelerate development of technology. So rather like the ventilator challenge, and they're all saying, and we've got in the UK quite a good small agri-robotics community, and that's because in the UK, because of Brexit, we've been busy working on a number of these challenges for a period of time. So we've got some good SMEs out there who've got some good tech, relatively high TRLs, 6, 7 probably, not yet 9, 10, but advancing at pace. And so we said to that community, well, what do you need to get your robots into industry next year? And they all said funding. That was short-term, fast-track funded, needed for innovation development. A lot of these SMEs haven't yet scaled up. So how do you scale up? How do you get CE certified? Who do you get to manufacture these robots? All those questions. And these are the questions facing the SME robotics community at the moment. What we also showed in the consultation was a massive shortage of engineers. So there was a real need for trained engineers. That's computer scientists and engineers to come in. So a real shortfall in the skill base in the sector. Lots of them are calling for evaluation sites. So where do they develop these robots? They need access to farms through COVID periods to try and do that. All of them are seeking collaboration. So that's multiple. They're all keen to work with other people to try and accelerate. and they all had a challenge around scaling. So, and that's, where do you go to get these machines made? How do you fund it? Who's going to provide the working capital? Who's going to provide the expertise? A very large amount of money from BAYS and Innovate UK to support us to push this forward, and we're still waiting for the results from that, but it's still in play in terms of securing that funding. So we do think we can accelerate these technologies. So what are the technologies we've got? And I'll just show you some videos now, Sarah, if that's okay. Oh no, let's go to the next one. Yeah, and this just shows. Yeah, next slide, please, Sarah. And this video, hopefully this will come out okay. Just shows you some of the work we're doing on software robotics at Lincoln. We work with Agri-Robotics, particularly at Lincoln, and Berry Gardens Growers, who are one of the UK's largest fruit producers. And Agri-Robotics, they built the hardware for the robot platform. This is the Saga robot, Thorvald robot. We've got a large number, there's about 12 of these now at Lincoln, either between us, which we own, or Saga own. This is a bit stilted, and here we have them as a fleet. It's a fantastic little robot. This one, it's about 150 kilos. Each wheel's got, it's four-wheel drive. Each wheel's got a 500 watt DC motor in it with exceptionally high torque for agricultural use. It's got a very high degree of autonomy, and this just shows the autonomy. So the top part of the screen shows robot view of the world. The bottom half shows the autonomous, the actual what the robot's doing in the real world. So it's got a very, very sophisticated autonomy stack, which can navigate through complex spaces. That enables us to do all sorts of things. We can work in tunnels, in greenhouses. It's the same robot, but a different modular design of the robot. And this is just showing the robot working with a UVC treatment. And that's a way to completely get rid of mildew with a light treatment. This shows the robot in Kent working in real life. We've got 3 of these in Kent now, where it's treating UVC to get rid of powdery crops. It works incredibly well, so you can grow fruit without the use of fungicides. We're using the robot for logistics support, and this is to support fruit pickers. So rather than carrying fruit from the end of rows to a rows, we're using the robots for fruit picking support. This just shows the robot in Kent on the test last year. The picker on the left's got a little, you can see a phone, presses the phone, that calls a robot. The robot then comes, picks the fruit up and takes it to a pack house. And this just shows a fisheye lens in the greenhouse, showing that going on. What you've got there is 2 pickers moving across the greenhouse. They're picking away, and eventually they will press a button, which calls the robot. And the robot, here it goes, going through there for a very complex space. You see robot 1, robot 2, and they whizzed back. There's robot 2 just gone back. So that autonomy is now working. And we've done that research at Lincoln, where we've got a robot fruit farm, which has got a full tunnel showing the face. And this is the picking head itself. So it's a cup, it envelops the fruit, the fruit then drops into a punnet and it's picked. And that's now at quite a high to speed that up. We're working on reducing food waste through forecasting, so you can put cameras on the robot, and this just shows the machine learning. It can detect fruit, maturity, weight, position, volume of the fruit in real time, and it can do this very, very accurately. This shows you can get the mass of the fruit, the distance of the fruit. We can reconstruct the 3D shape of every single fruit in a crop. This just shows the 3D reconstruction. And we can do that in 2D, and we can do that in 3D. So very, very sophisticated algorithms are in place, and we can even track fruit. So you can go in into a crop one day, and then you can find the next fruit and identify it the second day without a label. So this just shows that scanning through. We showed this on Countryfile. I'll just show this video if you can. There should be some, I don't know if you can see some sound. And this just shows one of our students on Country File. We challenged the presenters to beat the robot, and we challenged the presenter to beat our robot at fruit counting, so our robot won that. We challenged the presenter to beat our robot on fruit logistics, and we turned the robot down to half speed, so we had the presenter trying to beat our robot in terms of carrying fruit, and so we turned the robot down to half speed, and I think we drew on that one. But you know, we absolutely we're getting very, very close with these robots to commercial deployment and significant use of robots. So that is the robot moving autonomously in the fruit farm. So that's the sort of work that we're doing. And then next slide, please. I just want to show what we've been doing in COVID. I think that's the same one, Sarah. I think you need to go to the next slide, Sarah, if that's all right, please. Thank you. So how we work through COVID, and I just thought this would be interesting to IAgrE, and all of our work's been done through COVID on digital twin. And so we've done a full digital twin of the fruit picking robot during COVID in a package called Gazebo. It's got the full control stack, full ROS stack. It's got a full SolidWorks integration into CAD. It's got the full motion, and we can put the and it also simulates the full crop, the full tunnels, the full autonomy stack, the whole lot. So all of our work's been done in a digital twin. And my background is in agriculture, not in computer science, and I am just awe-inspired by what these people have done. And we worked in digital twin, and then this shows the first. This is a video from about 2 weeks ago. We've done the digital twin, you saw the digital twin, and then we tested the digital twin, and this is the first test. There were no other times when the robot's been out from the digital twin work over the winter, and here it goes. It picked the first fruit that it could find. So there you go. So I'm absolutely convinced big future of agricultural engineering is going to be around the use of digital twins, and we've been very active all the way through the winter, develop that digital twin for our fruit picking robot. And here it goes again. It's pick fruit 1. It's looking for the next fruit. Here it goes again. Pick fruit 2. Looking for the next fruit. Pick fruit 3. And you see it's picking direct into a punnet, so you don't have to go back to the robot every time you pick a fruit. And here it goes again. Picks fruit 4 or 5, and another one, gobbled it up. So it's getting close. The hard bit is those very dense clusters where you've got lots of occluded fruit, but we are making significant progress. Right, next slide, please, Sarah. So the unknown knowns. What we've shown is there's a great community out there with some high TRL projects out there. We don't know how quickly we can accelerate them. There's an urgent need to support industrial design and scaling. What I find in the robotics community is we need more focus on the engineering as well as the robotics. So the lots of very, very good computer scientists in robotics are coming into agriculture, and I think it would be really helpful if there's more of a focus on the engineering as well as the robotics. And then next slide, please, Sarah. And it just shows you the engineering challenges. So it's I think this is a really nice robot. So the battery pack is in box A. And it's 238 amp hour batteries, 48 volt. They can be bigger. You could put more capacity on the robot. Payloads. The weight of the robot's about 150 kilos. The payload's about 200 kilos. That will work for about 8 hours with the UVC light on. So it's quite chunky, quite powerful. The motors are interesting. There's 2 motors in this robot. In in B, you can see a cable going into a motor at the top of cell B. That motor is a 500 watt brushless DC motor, and that's on a chain drive to the wheel. And that's just an off-the-shelf motor. It's not specifically engineered, and it's a chain drive to get a very low torque motion. And then in box C, there's another motor, a second motor, which is the steering motor, and that gives you your four-wheel drive element. So it's a very simple design. It's very, very elegant. It's a very nice agricultural robot, but certainly would benefit from a lot more engineering design. And last slide, please, Sarah. And the unknown unknowns. And I got absolutely no doubt that we need to have a rethink about the way we do agriculture. And this is a bit extreme. This is a farm in Norway where some poor souls, I think it's in a ploughing match, had a bit of a disaster. And there is a notion that of having large fleets of small robots wandering over farms. I don't quite buy that. I do see the use of small robots for crop sensing, for when you think of replacing that, you have to think of physics. And I think a lot of people forget about the physics of agriculture and the bulk mass you've got to move when you're ploughing and the bulk weight you've got to carry. So I don't particularly see a world with many hundreds of small robots. I don't particularly see a world with many John Deere tractors like that. But maybe the world is somewhere in the middle. So maybe it's an intermediary thing, and we will need to think about how we electrify agriculture. We will be moving away from diesel at some stage in the future, and we need to think about those halfway houses. So maybe once we've had a go at software, we'll think around other agricultural vehicles. So that's it, Andy, if that's okay. If there's any questions, happy to take them. I'm sorry about the failure of me getting my own Zoom control, but thank you, Sarah. Yeah.
Thank you, Simon. That was excellent. Sarah, do you want to unmute everybody? And then if somebody wants to fire off with a question, in fact, if you unmute us, Jim Loynes could do his round of applause again, because I could see it, but I couldn't hear it. Sarah, can you unmute us?
I'm unmuting people, but they have to unmute themselves quite often, because I have to just ask them to unmute.
John Fox has even put the icon of clapping up. That's even better.
Oh, well done.
There, John.
I think I've asked everybody to unmute now. I think you've got autonomy to do so.
Super.
Yep.
Who's got a question? Who would like to ask a question? I think Jim's waving his hand.
I'm waving my hand. I don't know if I could do it any other way.
Fire away, Jim.
Probably at this stage, it's something that Simon can't answer. But I mean, it's all very well having the Saga robot and doing a good job with it as they are and developing it all. I have two questions in that regard. What does TRL stand for? And the second one is, how much does it cost?
Okay, yeah, so that's a really good question. TRL is technology readiness level. It goes from 1 to 9, depends on what scale. If it's 1, it's really basic research. If it's 6, it means you've got a prototype that you've tested once. If you're at 9, it means you've got something into industry. I think people misunderstand where the TRLs are in Agri-Robotics. People think they're higher than they are. So there's a temptation, particularly in the SME community, to over-egg it that they're closer to market than they are. And we find that actually they're probably a little bit further back. And then part of our work at Lincoln is really trying to push them on to get them up that TRL level as high as we possibly can. And I think with COVID, we're seeing certain things are moving very quickly, and they are scaling up those TRL levels very, very rapidly. The cost is a really good issue, and a lot of them, I do know the cost of that robot, and I think I'd be shot if I said what that was, but it's what the robot community are trying to do is look at the way that they sell into the market, and there's two options. One is you sell a robot to farmer, and the farmer then uses the robot. The other option that they're all looking at is selling it as a service. So the robot company, it maintains the control of the asset, but charges on the amount of kilos of fruit picked, and then it's the robot company's responsibility then to manage the full harvest, and which they'll get paid. So in some areas it's working. So the UVC treatment you saw with the lights in the tunnel, that's been charged on a per hectare basis. So the robot company goes in, I think they go twice a week, apply the UVC, and that's a certain price per hectare, similar to what you would pay for a fungicide treatment. So it's quite competitive against conventional agriculture. Then for fruit picking, for soft fruit, it costs the farmer about 40 pence a kilo for labour to pick a kilo of fruit. And I suspect that the robot companies will be thinking that the robot price will be around 40p a kilo, but it's a massive market, so there's lots of kilos, so revenue generation could be very high. What I don't think they really thought through is liabilities and all those consequential losses. So what happens if the robot breaks down and they can't pick fruit? Who's liable for all those sorts of things? And then they need to think through, and I know they're starting to do it, but they're not done it yet. It's things like personal liability. So what happens if the robot harms a picker by accident? Who's liable on the farm? So there's some quite complex governance and liability bits as well that need to be worked through, but they're certainly thinking about it, but they're not quite there yet.
Thanks.
Anyone else with another question? Someone wants to
Mike Thorvald asked a question by chat, which asked what career opportunities are there for students doing something like an MEng course in this area?
Oh, brilliant. Yeah, so loads and loads of opportunities. I think it's a really rich area. Certainly at Lincoln, we have a CDT, Centre for Doctoral Training for Agri-Robotics. We've got 50 PhDs funding through that, which we think is fantastic. Each of those 50 are case awards, so they're all with industry partners. And the industry partners can be anybody, but we've got people like John Deere, Syngenta, Dyson, those guys, lots of the smaller robotic companies. So if we think that's hopefully a big attractor for students to come in, and the way those PhDs are structured, it's Lincoln, Cambridge, and UEA. So you either register at Cambridge, do a PhD at Cambridge with a second supervisor at Lincoln or UEA, or you register at Lincoln, do one with a second supervisor at Cambridge or UEA, or so you get a really rounded support team around you to do your PhD. But it's a 3+1 PhD, so each student has to do a master's, and then you do your research phase. So there's lots of opportunities in that, but lots and lots of opportunities in robotics, whether you go into agri-robotics or whatever. I think it's, in my own view, that the industry's, the skill base is changing, it's transforming. There's a need for people with these new skills coming in. So I think it's fantastically interesting as a career. Well, you want to do it. So please get involved if you want to get involved. I think it's fantastic. I mean, I'm blown away by the digital twin work that our people have done. You know, they've been COVID isolated since March. We've had people who were stuck in Austria, who stayed in Austria, working away in a virtual simulation environment, which was just, a very nice team environment, and that's been very successful. And we put the robot into the real world, and it worked. Well, that's going to be part of the new way of working in the way we do engineering. And I just think, wow, it's great. But yeah.
I do have another question actually from Kadia, who's asked on chat. Can these robots be used in hot climates like the Caribbean?
Well, another interesting question. So we what we're looking at, and something we might start looking at next year, is low cost platforms for a wider range of terrains. And you think of a lot of agricultural it's not done with big tractors. You think of developing countries, there's not a lot of big tractors, but a lot of people are just spending their lives carrying lots of very heavy weights, water and stuff, and fertilizer bags, harvest bags. So we actually think there's quite a nice role, just as a very, very low cost platform just for carrying things around farms. That would be all terrain, and they would have to be working in all conditions. Certainly the design yet for a lot of these robots has not yet been verified for what I call all weather, all temperature deployments, but that's something that we are looking at the moment in terms of the way we design. So making sure that they are very, very robust for rain, wind, snow, temperature, and all those sorts of things.
I have a question.
I've got a couple of questions from the chat area. One's from Declan. Sorry, I'll come to you in a moment, Brian, if that's okay. Declan Flynn's just said, if the rollout of is robot as a service, I guess it won't be open source. The question is it open source, and what computer languages?
Yeah. Well, all my academics mates are really, really keen on open source, and all of our stuff is in ROS, and big chunks of it are available. All of my commercial mates are absolutely not open source. So we do have that sort of continual debate, and I wouldn't say conflict about how much the code is open source. All I can say though is Agri-Robotics would not have got to where it is today without that open source community. So very, very large proportions of the code that you'll see in a lot of Agri-Robotics is pulled in from the ROS community, which is open source. And so whilst I absolutely understand the commercial confidentiality, all those companies who are using ROS have massively benefited from the joint coding effort of hundreds and hundreds of developers globally, and they wouldn't have got to where they are without that access. So I am a champion of open source, but I recognise that there is a commercial need as well.
We've got another question here from William about LIDAR. So it's basically saying it's very expensive. Are you looking at automotive radar as it's lower cost and the technology is growing rapidly?
Yeah, we are. It's growing rapidly, and I think the sophistication of it is also growing rapidly. One of the great things the accelerated automation program I've done with Dave Ross was Innovate UK have an amazing network, and we've been introduced to the UK automotive supply chain, which is in the UK is very, very significant. So this morning I was talking to a company that makes the motors for four-wheel drive systems. Well, they might actually be, I showed you the Thorvald platform with the steering motor, so maybe that motor is a better motor than what we've got on the robot at the moment, because it's incredibly reliable, made by the millions and millions, very, very low cost. We're also talking to other automotive companies on the wheel motors. That's around eHub motors. Again, they're made for motorbikes, but we need slight mods to get the torque up. So we're talking to those sorts of people, and then we're also talking to automotive around low cost radars and LIDAR. So all those things. I think the what I've learned over the last few weeks is how big the automotive supply chain is and how small the agri supply chain is for these sorts of things. And if we can just get those collaborations going, we're all going to benefit.
Brian, you had a question.
Yeah, so there's a couple of questions really. One is the interesting use of UV and I wondered if are there any sort of problems with that in terms of moth kill or, killing insects at night, which of course are involved in pollination. The second question was looking at your wonderful picture of the tractor getting stuck in the mud at the end. And I was wondering if there has been any thought about using a kind of the system that was used for ploughing many moons ago with traction engines, where you actually pull the plough between two engines, and they could be robots. And so, a new approach to taking on those sorts of tasks.
Yeah, steam plough. Yeah. I've never really thought of it. When I think of ploughing, I always think of physics, and at the moment, electric batteries and physics aren't a good pairing because there isn't the energy density in the battery, unless you charge up to mains, and then you've got all sorts of issues on safety. So it depends. I think the exciting thing will be what happens with battery technology and the energy density around, well, not necessarily just energy density, but also the efficiency of deploying that power would be important. But I think that's got quite a way to go. On the UVC, it does work very well for fungal diseases, powdery mildew. It's not panacea, so it has to be part of an integrated pest management approach. It has been shown to have some impact on insects, particularly on things like thrips and things like that, but relatively relatively minor. But it's still early days, so there's lots of work going on in that space. On pollinators, it's not shown to have any negative effects, and there's been lots of development as well on UVC and UV light blocking greenhouse materials, which we've also been involved with at Lincoln. And it seems that bees, I don't know how they do it, can train themselves to be in UV denied environments. So in pollinator activity, we've not seen negative effects yet, but with all these things, it's very early days, and biology has a really good way of coming up behind you and biting you. Yeah, early days, but promising, I think. Yeah.
I see Andrew Landers has a question as well. Andrew, do you want to ask your question, which we're all desperately interested to know because it's about wine?
Yeah. Have you tried other crops with your harvesting technique?
Yeah, we worked really primarily on strawberries with that robot. There is a project on wine, an EU project in H2020, which we've got called Bacchus. Mm-hmm. That will be on grape harvesting. And that's just starting. Lots of interesting
mushrooms grown in.
Yeah, we have an active project with mushrooms with G's. Can't disclose too much about, but it's an obvious one. Many very expensive for picking. Many people involved and real problems with labour access. Really challenging on the robotics, because I think of mushroom picking a bit like a game of pick-up sticks, if you remember, where you drop the sticks and you have to move a stick without moving any of the other sticks. Because mushrooms grow in these really dense clusters with everything overlapping, you've got this massively complex game of pick-up sticks that you've got to do. So you've got to pick a mushroom without touching any other mushrooms. And it's that bit's the hard bit. So harvesting a mushroom is actually fairly simple with a robot, but doing it without damaging all the other, it's really challenging. So we are working in that space.
Yeah. Thanks.
I've got a few more. We've got a few more minutes, I think, Sarah, haven't we? If we're going to call a line at 2 o'clock, if everybody's happy with that. I'll start with, I realise I've skipped over one, and I'm going to start with a disclaimer, which I'm going to read out the questioner's name, and I'm going to apologise in advance if I've got it wrong. It says Ugbedi Victor Ahabia, so I apologise if I've got that completely wrong. But for businesses that want to invest in UK ag, what areas do you suggest should investments be directed to? We understand that the UK has specific areas where they want people and investors. I guess you could add to that intellect as well.
Yeah, in UK ag. Well, UK. I mean, I mean, my world experience is around application of Agri-Robotics. So I don't need to say any more about that. I think the other thing that really interests me is there are many data-driven technologies which are transforming agriculture, whether it's AI, machine learning. I mean, AI is a great one. I mean, if you think of all the software on a robot, it's all AI. It's all it's actionable insights from data-driven processing on the robot. So robotics is the great exemplar of how AI is transforming agriculture. But then there are many other applications as well: machine learning, image recognition, data platforms, 5G. I think 5G is really interesting for some applications. We're moving into a world with 5G where you can have really improved machine tractor control, where you've got one driver and autonomy. These technologies are really moving at pace, and we're just starting to get a view of them. Very exciting.
There's a couple of questions here which tie quite well together, actually. One from Nigel Penlington, and I'll go straight into the second question because I think the two fit together. So Nigel's question is, compete with a human, a robot person equivalent will have to pick one strawberry every 2.5 seconds. How far away are we? And do robots get viruses? Slightly tongue-in-cheek.
Yeah, 2.5 seconds is right. It's bang on. We on a single arm we're about every 6 seconds. But the thing about robots is you can make them parallel. So on the robot, one of the robots you saw on the video that had 2 arms, so you can use parallel. You can make it parallel. We absolutely recognise that we've got to be at least as productive as human workers. So that speed is now a big
UK developers in relation to the rest of the world.
That's a really good question. It would be wonderful if we had some other big agcos in the UK in terms of just robotics. I wouldn't say we're leading, but I think we're up there basically. If you really driven again a bit by Brexit, so the industry has been pulling the tech, which is good. So that's given us a bit of a lead. If I look around the rest of the world, where else would you go? There's a good community in the US, VC backed, and making some progress on harvesting. They're no further on than we are. Also, good community in China. So up there in the lead pack. I wouldn't say we're out in front, but we're at the front end of the peloton. Put it that way.
Yeah. Thank you very much for that, Simon. What I'm subject to the European Working Time Directive, will it? So you can, as long as there's enough gas. I make up slightly for the 6 second per strawberry work rate at the moment. We are just before 2 o'clock. Does anybody else have a burning question? Speak now or forever hold your peace. everyone who's asked a question. Quality of questioning has been very perceptive. And Simon, I think your candour's been excellent. You've given us really great insight into contemporary work and what's happening in a very exciting field. There will be, Sarah, you will correct me on this because I'll check my diary. There will be another fortnight's time on Thursday the 20th with Jim Wilson from Soil Essentials talking about tubazone. Potato harvesting, which is carrying on a bit of a theme of lunchtime technology lectures. Once again, Simon, thank you very much for your input today. Thank you everyone for your questions and for the quality of the discussion. So